Hello, today we're building a Pi-hole DNS ad blocker. This is a software that can block certain types of ads such as pop-up ads and banner ads across all your network devices. Typically, if you're trying to block ads on your PC for instance, you would install an ad blocking plugin to your browser, which you would have to do on every device on your network. However, it's not always possible to do on all devices such as smart TVs for instance. Another good thing about using this Pi-hole DNS blocker is that you can block web domains that you don't want to visit. So it can be helpful if you're trying to provide some form of parental control across your network to keep young children away from social media sites. What do you need? Well, because the Pi-hole solution is a lightweight application, it can run on a Raspberry Pi device. I purchased a Raspberry Pi kit to build this on as a gift for a friend, but the solution is so lightweight, even an old Raspberry Pi 3B with 512 MB RAM like this one here can handle it, not a problem. Things that you'll need for this. So obviously the Raspberry Pi, so in the kit provided you get a 2GB of RAM Raspberry Pi 4. You need an SD card, so this is provided and preloaded, but I'm going to wipe this and do this from scratch. You also get a nice case, and that's the main reason that I kind of bought the kit. You can also purchase independently, I might add, a different bottom for it, so that this completely hides the SD card to prevent it from accidentally being dislodged or removed. The kit also includes a Cat5 cable, though you can do it over Wi-Fi. Cat5 is much more preferred. It also comes with a official power supply, and it also comes with this HDMI lead, which I'm a bit unsure as to why, because we don't need an HDMI cable for this project, but handy to have for other projects I suppose. And you also get this wee cool sticker. To complete this project later on, you will require to gain access to your home router. So on the bottom of it there's usually a sticker, and it will have your admin username and password for logging into the router and being able to change some of the settings that are in there. I won't be able to cover every type of router that's out there. You'll have to refer to your own manufacturer's guide or supplier's guide. Now that we have all our required components, let's start configuring the system and putting it together. So we will start with the SD card. We'll get this plugged into program. Now we have the SD card plugged into the computer, we can switch to our desktop. If we open up our disk management, it might take a second. What we're looking for is the 32GB card that we've just put in, so that is it here, mounted as drive D. Now this already has the pre-allocation on it, so I am going to delete these volumes. So we want to format this entire 32 gigs of space as a FAT32, and we can perform a quick format, that's fine. And there you go, we've got a new volume FAT32. We can close this, and now we'll open up our Raspberry Pi imager and we will configure what we're running. So it is a Raspberry Pi 4 that came with the kit. The operating system we want to use will be the 64-bit operating system, however we do not need a desktop environment, so we will go to Raspberry Pi Other. We'll do the 64-bit Lite, so no desktop environment. And storage, we will choose that 32GB SD card that we've got sat there. We'll click on next, and would you like to apply custom settings? I typically do, so I will. I am going to call this what I intend it to be. Again, if you wanted to configure your wireless network interface, you can do here, but it is more advised that you use a hardwired Cat5 cable into your router. It's more stable, it's quicker, and it will prevent any issues with your devices later on. Would I like to apply my custom settings? Yes. All data will be erased. Yep, well we've already done that. Now that that's complete, we can remove the SD card from the PC and close this down. We have the SD card, and we will prep the Raspberry Pi, stick it in our case as well. Like I say, it's quite a snazzy looking little case. I've already stuck the heat pad on the bottom of there, so that is your heat sink for the board. I'll just line this up so it's sat in there nice and neat, and I'm going to put my different base on. So this base basically just has an extra lip here that prevents you from getting to the SD card at the back. There we go, nice built. SD card is not visible. Very nice. Next, power it up and plug it into the network. Lights are on, that's always a good sign. Now this device will be configured for DHCP and your router will apply an IP address to that automatically. We need to know what that address is in order to remote in and configure this. So here's how to find out. If you already have access to your router, which I do in my example, I can switch over to here and see that the name that I've called it, rpiehole EKM1. So this is the one that I am interested in, and it's been allocated an address of 10.1.3.74. Your IP address will be different. It'll be unique to every instance that you do this. Typically for home networks, your IP address will start 192.168, and then your third octet might either be a 0 or it might be a 1, and then the last octet, mine's is 74, yours will be a randomly assigned address from your router. So what we want to do is come back to our desktop and we will load this PuTTY software. Now PuTTY is just a network configuration tool that you can go in and remotely access different devices using SSH or serial comms ports, which would be USBs in modern day technology. So we know that our device is 10.1.3.74, so IP name or host is 10.1.3.74. The system will ask if you trust this device basically, so we are happy to accept that we know what that is, and we will log in. I've already pre-configured custom details. And that's us into that. Now let's just make this a little bigger. The next part is to obviously download and install the rpiehole DNS software. What we need to do now is sudo command so that we are the super user do, and this will start the download and install of the system. You will come across some prompts, so it says this installer will transform your device into a network-wide ad blocker. Good, that's what we want. Pi-hole is free but powered by donations, so if you do like their system, feel free to donate to them. Now they make a couple of important notes here. The Pi-hole is a server, so it needs a static IP address. We will come to this later on. There are a couple of ways that you can set the static IP address. The way that I personally am going to do it will be from the router, so you can reserve a specific IP address to it and then you always know what it is. So it now then asks for your upstream DNS provider. Now you can pick any type of upstream DNS provider that you like. I know Google is a typical one for 8.8.8.8 that a lot of people use. You've got Komodo there, which is an antivirus provided one, but what we're going to use is the Cloudflare one. So we'll navigate down to Cloudflare and select that one. Pi-hole relies on third-party lists to block ads. So typically you would get a list that has lots of sites within it which are known for providing ad services. So these lists would block those ads. This one is asking us, would you like to use the suggestion below of Stephen Black's unified host list? Yeah, we'll go with that one. Would you like to enable query login? Yep, not a problem. And for the privacy levels, I'm quite happy to show everything. So now the prompt is telling you to configure your devices to look at that IP address. Now we're going to change that later on, so don't worry too much about that, but what you do need to take a note of is admin webpage login. Okay, and that is it. That's installation complete from this point of view. Now we won't close the terminal just yet, we'll just knock that down to the bar out the road. I've since had my supervisor turn up, so I better get to work. And we will head over to our web browser. We know what the IP address of the device is, and we want to do /admin, and that loads up our Pi-hole page. Now it's asking for a password, and that is the password that you should have taken a note of during the terminal configuration. And again, this will be unique to every installation. So if I was to wipe this installation and start it again, it would issue me a completely different password the next time. And this brings you to your front page. As you can see from the dashboard, we've not had any queries or any requests coming into this server yet because none of our devices on the network are looking at this yet. So what we'll do is we'll set this with the static IP address, and we will change the configuration in our router to look at this device first. So let's open up a web page for your router. Now again, my system will be completely different to yours. What I'm looking for is my client, so my Pi-hole EKM1. I'll go into settings, and I want to use a fixed IP address for this, and I am going to make that 10.1.3. Now typically servers are at like the high end of a network, so for this example I would have it as say like 10.1.3.253 because 53 at the end is the port number for a DNS request. I already have a 253 in my network, so I'll just make this example 254 and we'll apply that change. Now the device isn't going to know until it's rebooted that it's got a different address, so what we'll do is we'll open our terminal window back up, and then I will do a sudo reboot. There we go. So we've lost connection while the device reboots. Now at this point you can close your terminal down because when we reconnect to the device we'll have to reconnect using the new IP address that we've assigned it. We'll go back into PuTTY and we've made it 10.1.3.254. There we go, so it sees it as a different device and it's asking us to log in. So that's us connected to the device. We know we're in the right device because of the IP address, but also there is the host name that I programmed in earlier on. So now that we've got our device set up with a static IP address, we need to go into our router and tell the router to forward all DNS requests to this device. So what we'll do now is we'll go into settings. I'll go to the network range that I am on. Now you will probably only have one network range, and if you locate where your DNS server settings are, so mine's are down here and it's currently set to auto. Now we'll uncheck that and then we'll set it to 10.1.3.254, which is the IP address our device is. We'll apply that change, connect to the device again on its new IP range, 10.1.3.254/admin. So we've still not had any requests yet. The device has recognised that there's 107,000 domains on the Steven Black list that it is blocking. Great, it's all set up, ready to go. What we actually need is devices to start making requests into this, and you'll see this start to populate. Now this device is not the first device that I've done. I've got one that's already on the network that I've been running with, and I'm going to change over to that one now so that you can see the live system with requests that have already previously been coming in. So I will connect to my one here, which as mentioned before will be my 253 one. And you can see there's a lot of data on this. So I've had a total of 34,000 queries, still counting, still going. So far I've had over 6,000 ads blocked recently. Now if you're just looking for a simple network ad blocker, that is it, and we can stop there. However, what I'm going to do, as I mentioned at the beginning of the video, is I'm going to show you how to block certain domains if you're wanting to stop somebody from getting to it. I'll use Facebook as an example. So we'll go ahead and we'll look at that next. So at the moment, if I just wanted to go to say www.facebook.com, it allows us to get to that landing page. Ideally, what we want is to not get to that, not get to anything else related to Facebook. So we don't want to be able to view posts or view people's accounts or anything like that. And I'll show you how to do that next. So go into your Pi-hole device, and here where you've got domains, Currently I don't have any allowed and I don't have any restricted. That's just the way that it's set by default. If we go into there, you can add a domain to be added. So we want to go facebook.com. Comment if you wanted to, so we know that that's going to be Facebook. And then you've got a tick box here that says add domain as wildcard. Check this box if you want to involve all subdomains. So that's back in reference to if there is an account.facebook.com or a post.facebook.com, depending on how they structure their list, it will include anything that is facebook.com. Check that as a yes. Add to denied domains. So there you go, you've now got Facebook domain is denied. In order to test that, what we'll do is we'll close our existing Facebook tab, browser settings, privacy and security, and then we've got cookies and site data. So I'm going to clear data for the last hour just from us visiting Facebook. There we go. Now you won't need to do that for anything else. This is purely just as a test. Because I've already visited the facebook.com domain, the PC knows where to go to resolve that. But what we're trying to do now is tell the PC to forget where that was. We'll get it to re-request it through Pi-hole, and Pi-hole should go, nah, you're not going there. As you'll have noticed, it has logged us out of Pi-hole again just because we've deleted cookies. So we can log back into that if we really want to. So we can see here now in the domains we've got 0 allowed and 1 is restricted, which is our Facebook one. So now I'm going to go back to the terminal just to update that list. It should update over time, but because we're just doing this in a short time scale, I'll refresh that list currently. So if we go sudo pi-hole -g, and there we go, that will update the database. Now if I go back to our web browser and go to www.facebook.com, it will not be able to find it. As mentioned, it does include all subdomains or other domains similar, so if you try to go to like facebook.co.uk, it can't find that either, and it should block the majority of the site from working, if not all of it. Again, I've just used Facebook as an example. I'll take that off again later on, but you could do it with anything else. Again, you could go to Instagram. So what we can do now is go back, go to the domains, add a domain to be blocked, take the wildcard and add it to blocked domains. And there you go. So Instagram.com is now unable to find that site as well. Now again, anything that you program into the Pi-hole applies to the entire network. So regardless as to whether it's a mobile phone or a PC or a smart television, if you try to manage the content that is going on, whether it's protecting younger people or people with addictions or anything, you don't need to worry about a different device in the network being able to access it or applying it to everything individually. This covers the whole lot. Now, unfortunately, as with anything, this is not a perfect solution and there are some limitations. It is not able to block ads from sites that host their own ads, have ads baked into their videos, or use a native application. This means that the device will not block ads from such sites as YouTube, Amazon Prime Video, Netflix, or any similarly based services. So that more or less wraps it up for this video. If you do this project yourself, let me know how you get on. If you have any questions, please let me know in the comments, and let me know, what would you use it for? Would you block sites? Would you just use it purely as an ad blocker? Yeah, give me an idea as to what you're using it for. Until next time, thanks again for watching, and if you enjoyed this video, please hit that like button.